Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to take a look at an example of how to divide a rational expression. So let's go ahead and get started here. So again, as you know, a rational expression is whenever you have, P over Q and, assuming that Q does not equal 0. We've talked about that before. And so when you're dividing, you're basically involving a polynomial is often what we're dealing with when we're talking about rational expressions. So let's go ahead and take a look at our example here. So we're going to have the example x to the third minus 8 over the quantity of, let's see here, 3x squared minus 6x plus 12 divided by, let's see here, x squared minus 4 over 6. This is what we're working with. Now, as you know, whenever you're dividing fractions, whenever you're dividing rational expressions, if you find the reciprocal of the second number, the number to the right of the division sign, and you can then just multiply it. So what we really have here, if I just had to, make this as simple as possible, is, just get rid of this. What we really have here essentially is, oh wait, I guess it's going to be more complicated than that. Oops. What we have here is basically, if I had to rewrite this, I would do it like the following. Let me make this nice and big for me for a second, and I will explain what I'm going to do. So what I really have here is, if I flip this second number here, and I flip this guy right here, this is essentially what I have. I will have the 6 on top now, and I will have the x squared minus 4 on the bottom, and I'll be multiplying now. That's basically what's happening. So as you know, whenever you're trying to divide fractions, you find the reciprocal for the second value, you flip it, and then now you can multiply straight across. But we're not quite ready for all that. There are several things that we can factor. Now, we're going to have a little bit of a problem with this guy right here. This is going to be a little bit of a problem. There's not a whole lot we can do to factor this. The only thing we can do is we can move the 3 to the outside. So what we'll end up having here is, if I had to just write it right here, is 3x squared minus 2x plus 4. That's the best we can do with the denominator for the fraction to the left of the multiplication sign. Now, on top of that, it's a little bit more interesting. Let's see here. Let me draw my line here. What we have here, and let me see if I can make this as clear as possible, is we have x3 minus 8. Now, if you're familiar with the sum of difference of cubes, this is a pattern for special types of factoring, special products of factoring. What you have essentially is that if I change this and I look at it as the following, so I could write it as, let's see here, x to the 3 minus 2 to the third. That's what we can also write it as. And when you have this pattern, you can use the sum of difference of cubes. This is a very common pattern for factoring values, where this is my a term, this is my b term, and it works out like this. So you have a minus b, which in our case would be x minus 2. Let me go ahead and draw this over here. That'll make it easier. So x minus 2, that's what we're working with. And then the rest of it is going to be a squared, which for us is going to be x squared, here this example, plus a times b, or b times a, whatever you want to do. So it'll be 2x. Notice how it's positive, even though it's a negative 2. That we're just following the pattern. And then you have b squared. So b squared is going to be plus 4 here in our example. And that's what we have so far. So you can see that we've dealt with one of the fractions. We've factored out as much as possible. For the bottom one, we just moved the 3 outside the parentheses to try to simplify it as much as possible. And for the x third minus 8, we followed this little pattern here for the sum of difference of cube pattern, which is commonly used for factoring. And now we can move on to the next, the next fraction. So let's move to the next page, get a little bit more space here. So I'm going to rewrite what's already been completed here. So up here at the top, I have x minus 2, x squared. Wait. x squared plus 2x plus 4. And then underneath that, let me close that out. I have 3x squared minus 2x plus, what was it, plus 4? Yeah, plus 4. That's what we have. Okay, so now we need to deal with our guy right here. That is our 6 over the x squared minus 4. Now, we can factor this right here. This guy right here, x squared minus 4, is very doable. We need something that when we multiply the factors, it'll come out to -4. And when we add them up, it'll come out to 0. This is the AC method again. And so the easy way to address that would be to look at the following. X minus 2, x plus 2. That's the way to deal with that. And so we've dealt with this right here. Let me go ahead and delete some of this to make it a little bit easier to find stuff. Oops, wrong color, excuse me. So we got this right here. We know what it is. And so I'm just going to write this right here real quick. And so let's see here. We got x plus 2, x minus 2. And so things are starting to work out nice and neat here. And so essentially what we have is the following. We have, if I can try to make this as neat as possible, we have 6, I'm putting that out in the front, x minus 2, x squared plus 2x plus 4, like this. And then in the denominator, we have 3, and then we have x squared minus 2x plus 4, and then we have x plus 2, x minus 2. So we need to look for like terms. So let's see what can cancel out what. So this x minus 2 is going to be canceled out by this guy right here, this x minus 2 at the top, and then this 6 is going to become a 2 because we're going to divide it by 3, and this is going to disappear and become a 1. And so what are we left with? We are left with the following. Let me see if I can draw this for you on a final page. We're left with 2x squared plus 2x plus 4 on the top. Let me close that out. And then on the bottom, we're left with x plus 2, x squared minus 2x plus 4. Again, just to make sure we know how we got that. So the x minus 2 are canceled out here. This leaves me with the x plus 2 at the bottom. The 6 and the 3 are canceled out as follows, because 6 divided by 3 is 2, and we're left with this. Now notice carefully, I have x squared plus 2x plus 4, and then I have x squared minus 2x plus 4. So these are different. I cannot deal with these as I would something else. Also, you cannot simplify or factor anymore this particular polynomial, this one or this one. So after many steps, we're actually done with our journey here. So let me see if I can go back and review what has happened in this video. So we started with this value right here. Well, actually, we didn't really start with this, but we started with the value where, okay, the x squared was on top and the 6 was on the bottom, and this used to be divided by. It used to be, but remember, whenever you are dividing fractions, if you flip, find the reciprocal for the second fraction, you can then just multiply straight across, and that's essentially what we did. But before we did the multiplication, we had to factor our various values. So what do we factor? Well, we factored this one, and this one. You can't factor 6, obviously. So for the x cubed minus 8, we turned that into x cubed minus 2 cubed, and you're able to follow the pattern for the sum of difference of cubes, which gave us this value right here in the top. Now, for the denominator of our fraction to the left of the multiplication sign, it was just a matter of moving the 3, outside the parentheses. And so that's how we got the bottom number down here. And so for the x squared minus 4, we dealt with that on the second page. And the x squared minus 4 came out x plus 2 in parentheses, x minus 2 in parentheses. Then we combined everything. So I moved my 6 down here in front, x minus 2, in parentheses, x squared plus 2x plus 4. All that is from our x cubed to minus 2 cubed pattern that we had. And then in the bottom, I had all this All I did first was I tried to remove like terms, so that's why the x minus 2 got crossed out, because this is also above. 6 divided by 3 is 2, and then we're left with all this information right here, and that's how we got our final answer right here. 2, because the 6 minus 3 is 2, that's why that's here. X squared plus 2x plus 4, this is what's left over from our x cubed minus 2 cubed original value. And also this information on the bottom, x plus 2 minus, or times x squared minus 2x plus 4. This x plus 2 came from right here when we were dealing with our x squared minus 4. Is left over from that. And this x squared minus 2x plus 4, that is left over from when we move this 3 here. That's kind of what happens. And so having done all that, we were able to finally complete dividing our rational expression. So I know a lot of stuff happened in this video, but the majority of this is review. If you're familiar with the AC method, if you're familiar with the finding the sum and the difference of cubes, if you will, the next step is just applying those principles when trying to divide a rational expression. So not that radical, although there's a lot of steps, because as the mathematics gets a little bit more complicated, there's a lot more assuming and skipping of steps, because this stuff was dealt with in prior lessons. So I hope this was useful for you. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.